In this second part of the tutorial, we are going to illustrate the use of probes in CAPSIM. If you already have the previous tutorial open, that's fine. If not, you can go to the File menu and click on Open and select Tutorial 1. And we have the tutorial as we left it from last time. In review, we have a digital communication link where we're generating bits of data. We are coding those bits into symbols plus or minus 1 and increasing the sampling rate by 8, actually forming impulses that drive the pulse shaping filter, which is split into two filters between transmitter and receiver. And we have a eye diagram probe which plots the eye diagram. What we're going to do is insert a probe at this connection because we're interested in what the spectrum looks like at this point, and also to look at the time domain signal and how it looks in the time domain. We have already looked at the eye diagram. To insert a probe, it's very simple. Basically, you have to select the connection. So you basically move the mouse over the connection until it's highlighted. You can see the highlight by these two little boxes here. Click on it and the connection menu will appear. Select probes. You'll be presented with a list of probes. In our case, we're interested in the spectrum probe. Notice this point right here. When I select the spectrum, the probe will appear. I can go and change parameters or do other things with the probe, but at this time we'll just go ahead and run the simulation to see what the results of the probe are. So let's run the simulation. Again, we get our previous eye diagram. We'll just park this in the corner here. We also have the spectrum of the signal and the signal in the time domain. And notice that the signal in the time domain, the eye diagram basically collapses the symbols per symbol over one baud interval to create the eye diagram, which is a very interesting way of looking at the signal. We'll get back to that later. Here we have the spectrum of the time domain of the signal, and the spectrum basically rolls off like a raised cosine. That's exactly what we have, is a raised cosine with 100% excess bandwidth, and that's what we see here. The spectrum is plotted in terms of samples because the spectrum is actually calculated using a fast Fourier transform. In this case, it's using 512 points, and a half of that is 256. We would rather have the spectrum plotted against frequency in megahertz, and let me explain how we do that. Basically, let's go back to the topology. We have to specify for the spectrum probe what the sampling rate is, in this case in megahertz. Now, how do we get the sampling rate? Let us assume that we have a source which is generating data at 1 megabits per second. As we indicated, the coder increases the sampling rate by a factor of 8. For every bit, it generates a symbol with 7 zeros followed by 7 zeros, which are impulses into the pulse shaping. So at this point, the sampling rate is 8 times the 1 megabits per second, which is 8 megasamples per second. So throughout these connections, the sampling rate is 8 megasamples per second. Now later on we'll actually do some decimation, etc., which will reduce the sampling rate, and you can always keep track of the sampling rate throughout the simulation. So let's get rid of these plots. It's very easy to do that in CAPSIM. Basically select this button in the toolbar for removing plots, and usually in CAPSIM you run a simulation, you generate plots, you look at the plots, and once you're done with them, you'd like to get rid of them. You're usually doing comparisons between plots. You can keep certain plots around many times. You run a simulation, you're done with it, you get rid of the plots. The next step is to show how you change a parameter in a probe. To do that, you have to select the probe. Go back to the signal where the probe is attached to, select it, and select probes again. You get the dialog box and you have a button here that says change parameter. Select that button that says change parameter. Select the probe you want to change the parameter for, in this case the spectrum probe. And in this spectrum probe, in the list of parameters, one thing we'd like to do is just change the sampling rate. So go across here, the sampling rate, we're going to change that to 8 megasamples per second. Now, if we run the simulation again, you'll see that the spectrum now, the x-axis is in megahertz and it goes up to 4 megahertz, which of course is correct because that's half the sampling rate. Now, one thing we'd like to do also is to look at the signal as it's generated and as it's mapped to symbols. And of course, we have it at this point plotted in terms of time domain and the spectrum, and of course the eye diagram. So we're going to add some more probes to the simulation. Let's go ahead and get rid of these plots for now. And again, it's very easy to add a probe. We're just going to go hit probe. In this case, we're only interested in the time domain. So we select the plot probe. Over here, we're interested in looking at the coder output, in which case the bits are mapped to symbols, in this case plus and minus 1, and the sampling rate is increased by a factor of 8. So let's go ahead and add a probe here, which is plot. Let's go ahead and change its parameter. And what I'd like to do is in the plot is to change the title to coder output. Notice that I put an underscore at the title, and this would be interpreted as a space. Also, ignore the number of points because by default probes are what you call static probes, which means that they automatically collect all the data that's presented to them and plot those results. So you don't have to worry about numbers. This number of samples is used for dynamic plotting, where you want to look at sort of blocks of data at a time. Okay, we're done with this. You can say OK, and we can run the simulation. Now you're going to get a number of plots. One is the eye diagram, the spectrum, the time domain after pulse shaping, the signal before pulse shaping, and recall that this is the coder output. We can also increase the size of a plot, and you notice that the symbols are mapped between 1 and minus 1, and of course there's gaps between the symbols, which is the actual each symbol representing an impulse. And notice that the number of points has increased compared to this plot, which is the plot of just the binary data, in which case we're going from 0 to 1. And you'll notice that, in fact, if we select the cursor, in this case, we have roughly 128 bits of information that's generated. And here we have 8 times that many samples that are generated due to increasing the sample. So let's go ahead and get rid of these plots. And we have illustrated the power of probes and how easy it is to add probes in CAPSIM. Many times you might want to get rid of these probes. That's very simple. Just go select the connection and delete probes. We'll keep the spectrum probe handy. Run the simulation again. Again, you get the eye diagram, the spectrum, and the time domain. That concludes our tutorial on adding probes, changing probe parameters, and also deleting probes.